present about the application of conic section in real life. Our group name is BDJSM and we are from group 6. So now this is the introduction part. My name is AUG23 and these two are my group members. They Chu Ching and Tan Yi En. So now we are going to present about the application of conic section. As we know, the conic section have 4 examples, which are circle, ellipse, hyperbola, and parabola. So what is conic section? A conic section means the curve obtained by the intersection of a plane and a cone. Why do we use the conic section? The application of conic section are numerous. They are used in many fields such as physics, orbital mechanics, and optics. In addition, in each conic section is a locus of point, a set of points that satisfy a condition. Their status as a loci of point allow them to be used in practical problems in which the location of an object can be varied, but it needs to meet certain conditions. Understanding the coordinate geometry of conic section allows us to model this situation with the equation of conic section. So now I will pass to Ziqing.
So now we are going to discuss about ellipse. An ellipse usually looks like a squash circle. In fact, a circle is a special kind of ellipse. Any points on an ellipse has the same sum of distance to 2 focus points. The line through the both foci, called major axis, intersect with the ellipse at the major vertices. The midpoint of the line segment joining the vertices is called the center. The line passing through the center and perpendicular with major axis called the minor axis. Minor axis intersect with the ellipse at the minor vertices. The line segment joining 2 points passing through each foci and perpendicular to the major axis is called the lattice vector. So this table shows the equation of the ellipse with center at origin 0, 0. So we go through example. So example 1. Determine the equation of ellipse with center 0, 0, foci on y-axis, length of major axis and minor axis are 20 units and 8 units respectively. Hence, sketch the graph. So from the question, we know that our center is 0, 0 and foci on the y-axis. So based on the table, we know that foci on y-axis is vertical major axis. So our length of major axis is 2b and our length of minor axis is 2a. So we use these two formula and substitute 2b equal to 20, b equal to 10, 2a equal to 8, so we get a equal to 4. So after we find a and b, we can find the foci from the, based on the table, we know that foci equal to 0 plus minus c. So how we can get c? We can use the formula. C squared equal to b squared minus a squared. So we can get c and c equal to square root 84. So we substitute c equal to square root 84 into the equation. So we get 0 square root 84 and 0 negative square root 84. After that, we can find vertices. We use this formula 0 plus minus b and plus minus a 0. So we can get major vertices, which is 0, 10 and 0, negative 10, and minor vertices is 4, 0 and negative 0. So this is our graph, and we got major vertices and minor vertices. So from the graph, we know that. So we can get the equation from standard equation x squared over a squared plus y squared over b squared equal to 1. So we substitute a equal to 4 and b equal to 10. So we get the equation x squared over 60 plus y squared over 100 equal to 1. Stop.
So now we are going to discuss about the example 2, which is we have to find the foci and the length of the lattice rectum of ellipse, which is 16x squared plus y squared equals to 16. Hence, sketch the graph. So based on the table, we know that the standard equation have to be 1. Therefore, from the equation we have to divide by 16 and form a new equation, which is the x squared plus y squared over 16 equals to 1. Therefore, we have to find the a and the b. If the value of b is larger than a, then the shape of the ellipse have to be the vertical one. Then the center is 0, 0, and now we go to the vertices. Vertices, we have the major vertices and the minor vertices. For the major one, 0 plus minus b, then we find out the 0, 4 and 0, negative 4. For the minor one, we find out that is 1, 0 and negative 1, 0. For the foci, we have to find out the c. So from the equation of the c squared equals to b squared minus s squared, we found the c is equal to the square root of the 15. Therefore, we sub into the equation of foci, then we find out the foci is 0 and square root of the 15 and 0 minus square root of 15. Now for the length of the major and the length of the minor, we use the 2b and 2a, then we find out the length of the major is 8 and the length of the minor is 2. So the last is the length of the lattice rectum. We're using the equation 2s squared over b, then we find out the length is 1 over 2. So from the above information, we can sketch the graph.
So this table shows the equation of the ellipse with central at hk. So we go through the example. Determine the equation of the ellipse using the following information. Then sketch the ellipse. Foci equal to 4 plus minus square root 5 and 3. Vertices equal to 0, 3 and 8, 3. So first, foci is equal to h plus minus ck. So from this formula, we can know that the c is equal to square root 5 and c squared is equal to 5. Then the central is equal to hk. We substitute the values of h and k, so we can get the central is equal to 4, 3. The vertices is equal to h plus minus a and k. So we substitute the values and we can get 4 plus minus a and 3. 4 plus a equal to 8, 4 minus a equal to 0. So we can get the values of a is equal to 4. So here we have the values of a and c. So we can find the b from the formula c squared equal to a squared minus b squared. So we can substitute the values and get b equal to square root 11. The length of lattice rectum is equal to 2b squared over a. So we substitute the values of b squared and a, so we can get the value is 11 over 2. From the standard equation, x minus h squared over a squared plus c minus k squared over b squared equal to 1. So we substitute the values and we can get x minus 4 squared over 16 plus y minus 3 squared over 11 equal to 1. So this is our graph. In conclusion, the applications and examples of ellipse in real life are as, for example, mirrors and the elliptical orbits of planets and satellites. From the calculations, we can know that the object's shape is ellipse and its size through sketching the graph using the foci, vertices, and length of lattice rectum. By using the formula, we also can know the equation of the ellipse. Here are our references. That's all. Thank you.